Okay, so suppose you were asked to calculate the rate law based on this experimental data. We have a table here representing um, the result of the reaction, how the initial rate changes as the concentration of A and B varies. So we would have to look at the way to approach this is to look at the data and so look at the equations. We're going to try to find out a case where we could keep A constant or we could keep B constant. We're going to try one at a time. So looking at the equations, sorry, looking at experimental 1 and experimental 2 result, we see that A is kept constant here. When A is kept constant, B changes. In this case, we can see that B is doubled because we're starting at 0.02 and we're ending up with 0.04. So when B is doubled, we're going to see how the initial rate is affected. When this is doubled, the initial rate is also doubled. From this information, we could know that the rate is proportional to B to the 1 power. So when we double this, the rate is doubled. So let's try to look at a case where we have B constant and A is vary. So we're looking at experiment result for 1 and 3. We see B is kept constant here. So in this case, A is doubled. When A is doubled, the initial rate moves from 1.2 to 2.4. This is also doubled. So this is also telling us that the rate is proportional to A raised to the power 1 as well. So from this, we can write our rate law. So rate would be equal to K, constant, A to the 1, but we don't normally put the 1, we just leave it. We'll assume if there's nothing there is a 1, and B to the 1, right? Now, questions will also ask you, sometime a question will ask you, what is the value of K? So you look at you could choose any of the experimental data. Let's say we choose experiment 3. So we can tell that from this, the rate, which is 2.4 times 10 to the minus 2, the unit is moles per second, concentration per second. So we have m to the second over what the value for A is. A is, since we're looking at 3, A is going to be 0.20, and the unit again is big M. If we look up, the unit is big M, and times B, which is 0.020 times big M. So this will give us the value of K, because rate over A and B gives us K. So from this, we will find that K will be equal to 6 m to the minus 1 second to the minus 1. Okay, so that's how we would calculate the rate law and also determine the value of K. Let's try another example. Again, we're given an experimental data, and the same approach, we're going to look to see when we can have A constant and when we can have B constant. So we're looking at examples, experiment 2 and 3. We can see that A is kept constant here. When A is constant, we see B varies. When B, this case, B is doubled. When B is doubled, the rate was unaffected. If the rate is unaffected, therefore we can know rate is not affected by B. So rate is proportional to B raised to the 0 power. Right, so this anything raised to the power of 0 is equal to 1, but just leave it at b to the 0 power for now. Now we're going to look for when b is constant. Looking at equation, looking at experiment 1 and 3, we can see b is kept constant here. When b is kept constant, we can see a is doubled. When a is doubled, because we're moving from point 1 to point 2, what's happening to the rate? We have 3.0 times 10 to the minus 4 to 1.2 times 10 to the minus 3. If you plug this into your calculators, you're going to realize that initial rate went up by 4 times. So we double b, and this went up by 4 times. This is telling us that it's the second order. Because when this is doubled, anything, so we have, if you think about it, 2, what is 2 squared? That goes up by 4. Alright, so when a is doubled, the rate, initial rate went up by 4 times. So we know this order has to be to the second power. So from this, we can write our rate expression. Rate is equal to k a to the 2 b to the naught. But we don't normally have this, so we're going to just put it as rate is equal to k a to the 2. Now, so if you're asked what is the overall order for this reaction, the overall order would be equal to 2, because this is 2 plus 0, which is 2. For the example we did before, the overall order is also equal to 2. This is 1 plus 1. So we could say the overall order is equal to 2. Okay, so let's see if we could determine the value for k from this. So k again will be equal to rate over a square. So we got to choose one of these experimental data. We could choose the first one, since we look at the third one, the previous example. So here our rate is 3.0 times 10 to the minus 4. That's 3.0 times 10 to the minus 4, and that's moles per second. And A, what's the value for A? A is 0.1 and it's square, so we're going to do it 2 times. So 0.10 to the m times 0.10 to the m. So if you plug this into your calculators, you will get k is equal to 3.0 times 10 to the minus 2 moles to the minus 1 second to the minus 1. So that's how you can determine the rate law, the value of k, and the overall order. Hope this helps.